Good morning. Uh, my name is Zaffer. I'm working as assistant professor in Tala Padmavati Engineering College, and I have been allotted DMM 2 for polytechnic students because of students haven't coming from the right first class, and most of the students have missed a few initial topics, and when they have come recently, they didn't understand what I'm teaching. So I decided to make a video for those students and so that those students can understand, because I don't want any blank faces in the classroom, and I want everyone to pass. Unless you come regularly for topics like DMM2, then I guess you don't get the basics, because I have seen that most of the students have failed in DMM1 because they don't have a calculator with them, and the other book is design data book. Unless you don't have design data book, you can't remember all the formulas in DMM1 and DMM2. There are n number of formulas. For each topic they have given a separate formula. So it's up to you. You have to decide on yourself whether you want to get out of the subject or stay with it and extend 1 year after your diploma and write that subject in your supplementary. Unless you work hard at least 10% than others do, you won't get extra marks. The competition is very heavy that if you don't study hard, if you don't have sufficient number of percent, then you can't apply for central government jobs, state government jobs, or in the private organization. Everywhere there is a certain percent, and students with less number of backlogs are preferred rather than those who got more backlogs. Having backlogs is not a problem, but how you clear it, how you fix it, that is very important. Okay, no one asks you how many backlogs you have, but the one who asks you is, have you done your diploma or have you done your engineering? That is what you want. So the very first topic in our first chapter, belt drives and chain drives, is power drivers. Power drivers are nothing but the ability to do work. Okay, if a machine has to be moved from one direction to another direction, or an object has to be moved, it needs some force, some power to to move that. The ability, the initial movement, you need that. Okay, but that power is required. Here in power drivers, there are different types. The basic definition of power drivers is nothing but the mechanism used to transmit power from one machine to other machine are called as power drivers. And in power drivers, there are four types. Now, what is power drivers is, in simple words, the ability. Now, let's think. This is in Singareni mines. You'll find a lot of elevators, and elevators are used. Generally, elevators are used in airports, railway station, to transmit, to to move a object from one direction to another direction. This is the basic definition of elevators. Okay. Now in elevators we use power drivers. Okay. ఏం లేదండి, పవర్ డ్రైవర్స్ అంటే ఒక ఆబ్జెక్ట్ ని ఇంకొక ప్లేస్ దగ్గర తీసుకువెళ్తున్నాం. ఆ తీసుకువెళ్ళే మెకానిజం లో చాలా డిఫరెంట్ ఉంటాయి. ఆ డిఫరెంట్ టైప్స్ లో ఎలక్ట్రికల్ డ్రైవ్స్, hydraulic drives, mechanical drives, pneumatic drives. In electrical drives, we use electricity to transfer. How we transfer those drives we'll learn in the upcoming classes. These are the definitions: electrical drives, mechanical drives, hydraulic drives, and pneumatic drives. In electrical drives, we use electricity to transfer an object from one direction to one place to another place. In mechanical drives, we use chains, belts, mechanical things, elevators, pulleys to transfer power. In hydraulic drives, we use water, oil. In pneumatic drives, we use air. So, in these are used in generally these four types are used in industries. Okay, types of mechanical drives. In mechanical power drivers. So, because we are mechanical engineer, we will learn mechanical drives. Pneumatics and hydraulics are the main structure in pneumatic, hydraulic, and pneumatic drives is mechanical drives only. They use same mechanism to run those ones. Okay, in the bridges we use hydraulic drives. These are very effective and accurate. Pneumatic drives are more powerful than hydraulic drives. This is the latest technology. So in power drives, mechanical power drives, this comes in your 2 marks questions. Okay, hydraulic drives and flexible drives. Rigid drives, sorry. In rigid drives, the mechanism is rigid. Okay, in rigid drives, the mechanism is rigid and power transmitted is also fixed one. Like in gear types, the gears are fixed. Okay, this is a gear and it is rotating. The other gear. Here, this one is the only gear which is running on power. This has a power to do some work. Okay, it is doing power on this ideal gear. Because of this gear is rotating. This is nothing but fixed drivers. These are these are topic in power drivers. Okay, power drivers are nothing but it is used to transfer one transmit of is a mechanism of transmission of power from one driver to another driver are called as power drivers. Because here you can see this mechanism is turning out this one, and these are fixed one. These can't be movable. Like in flexible drivers, these are this can be found in floor mills. Okay, ఫ్లోర్ మిల్స్. ఇక్కడ నా గిర్ని దగ్గర వెళ్తే అక్కడ మీరు చూడవచ్చు. Floor mills. In floor mills, you will find this type of belt drives. These are flexible drives. This can be moved in any place, and here driving wheel is this one. This is a main engine which is running on power, and because of this engine, this machine which is ideal, which is has no engine in it, it is running. Okay, DMM2 is all imagination. You need a lot of imagination. Okay, so this is what flexible drivers. In rigid drivers, friction drives, gear drives are examples, and in flexible drivers, belt drives, chain drives, and rope drives are example. We can use either belt for transmission of power, chains for transmission of power. If the chain drives are used, we have to use gear types. But you can transfer power to the other driver. Okay, here, and these are rope drives. The main two power transmission mechanical elements are driving shaft and driven shaft. Okay, this is driving shaft which has power, and this one is driven shaft. Because of driving shaft, driven shaft is rotating. In rigid drivers, we have rigid drives are direct contact or in direct contact. In flexible drivers, they are not in direct contact. We can add one more machine. That's why it's called as flexible to rotate. Because of one machine, we are rotating two machines. It has power. Because of this power, because of belt, we are rotating another machine. Okay, we'll learn in the upcoming classes in detail. So this is the basic definition. These are basic definitions. Okay. Okay. Factors to be considered for selecting of power drives. Let me change the color. So power to be transmitted between two shafts. Okay, these are factors. If if you want to transfer power from one place to another, one machine to the other machine, you have to consider how much power has to be transferred and central distance between two shafts. These are shafts. I'm not good at drawing, but I'm just managing because this is not my hand. I have to use pencil over here. These are rigid drivers. These are flexible drivers. Okay, flexible drivers. So you have to consider whether what type of mechanism you have to use. If you are transferring power which has very less space, then you can use gear drivers and rigid drivers. Or if you have maximum space, here is one machine and another machine is somewhere else here, right? Or if we think the machine other machine is over here, then with the help of belts we'll connect it out. Okay, so this is what the central distance between two shafts. Factors, these are the factors. Velocity ratios, how much velocity you need to direct contact has good velocity efficiency because direct there will be less losses. Okay. Maintenance cost is less for this one because we are not using any oil for lubrication. In gears we have to use lubrication for easy movement of gears. Okay, initial cost is for this is very less. This is for this it is more because you have to connect, you have to use the cost of metal is very high. Here we are using belt only. Yeah, belt is very less costly. Overall dimensions, how much space you are requiring, floor space, I said, efficiency. These are the differentiations. I have given notes to your friends. You have to refer it. Now belt drives. These are the example of. One second. Just wait for 1 second. I have to check whether it's recording or not. I guess it is recording. So in belt drives are flexible. Okay, the reason why flexible we'll learn here. These are used to transmission of power from one shaft. These are the shaft. One shaft to other shaft are called as belt drives. You are using belt over here, and the motion of direction is here. And this is how it rotates. It rotates this direction. Driver, it is connected to the machine, and it is a driven, which has no machine but it does some work. Now, why belt drives are called as flexible? I will give a best example for you. If you think this is a machine which is rotating, this is a pulley which is rotating with the help of a machine. Okay, with the help of power, it is rotating, and this driver is rotating because of this one, because of power. Now we can add one more pulley over here or shaft, and we can connect to this. Here, as I said, that DMM2 is all about imagination. You can think that because of this machine is running, and because of this shaft, we have connected this one to other machine, which is ideal. Now, because of this machine, we are running two machines. Okay, it is totally flexible because of this one. We can say that is flexible, but in gears, we can add on the other side, but we can add in any direction. We can also add in this direction and anywhere we can do. Okay, because of the flexibility of we can provide the power in any far distance. Here is one machine and here is one machine. We can transfer the power, but whereas in rigid drivers, in gear drivers, it needs direct contact. Okay, hope you understood that. Okay, principle of belted drives. In belted drives we have one driver which is driving the vehicle, driving the motor, and this is a driven one which is running because of this one. A belted drive consists of endless belt wrapping tightly around the driving pulley and driven pulley, which are mounted on two different shafts known as driving shaft and driven shaft. This is a basic definition, basic principle. I want this definition to be very exact in the answer sheet. If you need good score, good marks, 2 by 2, how much marks for, I don't know how many marks for two types questions, but if you need the same marks which are allotted for that, then you have to write the very basic definition, because I don't want any meaning to be changing. The meaning is if the meaning is exact and the words are used very professional, then I can give you the same marks which are allotted, but not less than that. Okay, here should not the belt drive should not exceed 10 meters. These are the conditions, and the minimum distance should be 3.5 times of the larger diameter pulley. Okay, the condition is the diameter of the and the distance minimum distance should be not less than 3.5 times of the diameter of the larger pulley. The larger pulley is 2 meters in diameter, then you have to calculate how much it is. 7. The minimum distance should be 7. This is the diameter. If you are thinking, it may be 3 mm, 3 meters. Yeah, on that we have to select the minimum distance. The advantages are basic design. It has no complex design. It can transfer power in the longer distance. Okay. Maintenance cost is low. It is smooth, shock loads, damp vibration effectively. But there are some losses we'll learn in the upcoming classes. No lubricant is required. Occupies more space, velocity ratios are very small, shorter in life, 5 years. Again, we have to change the belt to increase the lifespan. It has some low efficiency because of I have said some losses. We'll learn those losses in the upcoming classes. Belt drives are used in automobiles. Okay, now vehicles we use for transmission of power. Floor means conveyors, as I said, conveyors, electric motors, okay, compressors, blowers, sawmills, crushers, textile industries, and industrial machine tools. Classification of belt drives. Classification we have light drives, medium drives, and heavy drives. In light drives, the transmission of power is only up to 12 meters per second. So with the need we use 3 drivers. In belt drives we use light drives, medium drives, and heavy drives. Okay. For medium drives we use 12 to 24 meters per second. Heavy drives 24 meters per second. Light drives we use in machine tools. The medium drives with the need we change. There are many machine tools. Okay. With the respectives we use different speeds. Okay. As I said, heavy drives are used in generators where the maximum power is 24 meters per second. Now belt materials. There are 5 types of belt materials used in belt drives. Okay, we use leather, fabrics, rubber, Balata materials are nothing but rubber. It's a sort of rubber which are derived from rubber. So I didn't give balata materials in your notes. Natural and synthetic rubbers. These are also are derivation of rubbers. So desirable properties for the belted drive should have is it should have a high coefficient of friction. Unless it has high coefficient of friction, it will not rotate with the machine. Okay, the machine it may not, it should have high coefficient of friction, and tensile stress should be maximum. Okay, so they must have high tensile strength. As I said earlier, they should have low rigidity, and the wear resistance should be high. In leather belts, to use leather. I have given this notes tab. This is the general topics. You can read it out. So in joining belt joints, we use three types, three processes. Cementing, we add lubrication over here to join this belt and this belt. Lacing, we use threads. These are threads we use to join uh, these two belts, because the belt is because the belt has to be mounted on the pulleys. It has to be fixed at one end, right? So we use three processes: cementing, lacing, and middle joining. In the middle joining, we use metals. We fix it. We pull that two joints, and we fix one pin over here, and we just hammer it out, and we can fix it out. Okay, these are the two types we use. Okay, we use to fix these two types. Cementings are very effective. These are 80% stronger, and lacing we use threads, uh, and threads like wires we use tanned or wires. Okay, 50% effective. These are 50% stronger if you are using laced ones. Metal fastening are 25% stronger. Now we come to the velocity ratio of the belt drives. Velocity ratio of the belt drive is equal to velocity of the driven pulley by speed of the driver. This is the driver, and this is the driven one. Velocity ratio is equal to, now speed is defined of the pulley. Driver is nothing but which is driving. Driven is nothing but which is driven by the driving vehicle. Okay, some sorry some uh, I'll drink some water. Okay. This is a D1 and this is D2. D1 in the diameter. D1 is the diameter of the driver pulley, and D2 is the diameter of the driven pulley. And this is the belt, and this is the motion of the belt. Okay, this is the concept. Now we'll derive an equation for velocity of the belt drive. There are few steps. There are many ways to derive the velocity ratio of the belt drive, but we'll use a simple one. I'll show you the two types. Okay, we'll use the two types. Now, the very first is, if you think if you think this is the driver pulley, the contact area of the belt is only half of it. Okay, okay, the connection over here is off, and this part is not in contact. Okay, this part is not in contact. So it is circumference of the circle. You can think that as circumference of the circle. Okay, circumference of the circle C is equal to pi d, and this is circumference of this circle 1 and circumference of the circle 2. Here also we have only half circle contact, and this circle is not in contact. C2 is equal to pi d1 pi d2, and n1 is the speed of the circle. N1 is the speed of the circle. N1 and okay, if the velocity of the circumference of this one and this one is equal, I mean, if the the, the contact area of pulley 1 and pulley 2 is equal, then we have the ratio is equal to, I will write here, pi d1 n1 is equal to pi d2 and pi gets cancelled because it's constant. D1 and d1 by d2 is equal to n2 by n1. This is the basic velocity ratio formula. Okay, if you know peripheral velocity of the belt concept, you can do it very easily, because this is a derivation though for velocity ratio, but you have to remember the peripheral velocity of the belt is given by, this is a formula of peripheral velocity you need to learn. By 60. Peripheral velocity at pulley v1 periphery velocity at v1 is equal to pi dm by 60, and the periphery velocity at the second wheel is equal to pi dm into by 60. Okay, this is the concept, and from that you will when velocity ratios velocity of v1 is same as v2, we'll get this derivation. Okay, but you have to remember this. You'll get direct question. You'll get a direct question where velocity of v1, velocity of a belt drive, velocity of a pulley is this much and diameter this much. I mean the speed of a pulley is 100 rpm, and diameter of a pulley is 60 rpm, 60 mm. Then what is find the velocity of the pulley? You will get direct question. I have to use this formula, and you have to do. As I have said you in the earlier class, that this is a derivation part. Okay, here if the belt in the question, if we ask you considering the belt thickness, then we have to add thickness for the diameter. It is here I will explain you how. This is a belt. It is rotating with certain velocity, and the thickness of the belt is considered from here until the diameter. So we add thickness of the belt to the question. I mean to the value of the diameter. Okay, here we learn the slips, how losses are occurred. Just a second. So slip in the belt. The remaining topics are covered in the next video.